Hello, in this video we'll continue in section 5 going into part 2. We're still going to be finding the equations of lines, but now we're going to talk about special sets of lines when we look at lines that are parallel to each other or lines that are perpendicular to each other. Now, when we first start this off, just a little reminder, most people have seen these concepts before. The idea of parallel lines are simply two lines that never hit each other. So here I'm just using my pens. Here's a quick picture from a graph. Two lines that just run and never hit each other. That's what we're talking about when we say parallel. When we talk about perpendicular, now this is where the parallels of math, well, if these lines never hit each other, then people think, well, perpendicular lines that do hit each other, but it's more specific than just that. If we talk about perpendicular lines, not only are we looking at points that intersect, we are specifically talking about lines that intersect at a right angle. That's the definition of perpendicular. So that's a reminder, but what does it take? What does it take for two lines to be parallel? Whether they're going this way or if I flip it the other way and have them go this way, doesn't matter, they're not touching. So what does it take for two lines like this to not touch? It's where the pattern of our slope comes in. That whatever action this is taking to go from one point to the next and connect the dots, this has to do that exact same action. Whatever the slope is here, we have the same slope here. So that's not the definition of parallel lines, but that's the key fact we need to know. Parallel lines have the same slope. Now, when it comes to perpendicular, not quite as lovely. Again, it's not just enough that they intersect. It would have to be something where they are intersecting at this perfect right angle. So here, that would roughly be a line like this. Okay, if it was up here, it'd be a line like this. But that's what we're looking at, so that this is actually a 90-degree right angle. Well, what does that tell me? What do these two lines have in common? They clearly don't have the same slope. This one has a negative slope, this one has a positive. But what do they have in common? There is a slope property, and that if we have perpendicular lines, their slopes are negative reciprocals of each other. Now, even that, we're going to do a few problems to really make it clear what we mean by that. But looking over here, if this has a slope of -1/2, down 1, right 2, this would have a slope +2 over 1. The negative became a positive as I went from one to the other, and what was 1/2 here became +2 over 1 here. If it wasn't that clean, if maybe this was a slope of -2/3, down 2, right 3, actually that looks pretty close to what it might be, down 2, right 3, well, this would have a slope +3, up 3, right 2. That's the relation between them. So that's what we want to get used to, that changing the sign and flipping the fraction. So we're going to move right into a little exercise. What is the slope of the line? And we're going to do two parts here. Part A, we're going to say parallel, and part B, we'll say perpendicular to the given line. So number one, I just start you off, the slope of our given line is positive, let's go +3 over 7. My original line has a slope of +3 over 7. So part A, what's the slope of the parallel line? Well, parallel lines have the same slope. So if my original line had a slope of 3 over 7, was going up 3 over right 7, well then my parallel line has that exact same slope. Part B, if my line is perpendicular to this line, well, that's the negative reciprocal. This started positive, so my perpendicular will have a negative slope. This was a 3/7. I will flip it. That's what the reciprocal is. The reciprocal is the flip. I will flip it and get -7/3. Let's do that again. Number 2, what if my slope starts off as +5/2? Doesn't matter, it's an improper fraction, that's fine. It's just up 5, right 2. Nothing wrong with that. Part A, my line is parallel to this line. So this line has a slope of 5/2. My line has a slope of 5/2. Part B, now I'm looking at the perpendicular line. So again, the negative reciprocal, this will become, started positive, so it becomes negative, and then I flip my fraction. And what people want to start realizing is that if you do that again, you end up right back where you started. So if I reverse the question, that if this was the original line and this was its slope, well, then this one would then be the perpendicular one. I started negative, hit it with another negative, it becomes positive, flip the fraction, 7/3 becomes 3/7. Start here. If my original had a slope of -2/5, hit it with another negative, that becomes a positive, and then flip the 2/5 to become 5/2. Let's just do one more like this, and now let's start off number 3. My given line is y equals -1/4 x plus 3. The big difference is that now I'm giving you the equation of the original line. So first step, what's the slope? Well, there it is. It's already nicely in mx plus b form, so I could easily identify this line has a slope of -1/4, and now I'm right back where I was back over here. That now I could say, okay, so my parallel line has that exact same slope. So what was -1/4 before is still -1/4 after. And that for perpendicular, hit it with another negative. That's where people misunderstand this. They see negative reciprocal, so they think the perpendicular always has to be negative. They miss the idea that you're hitting it with a negative. And since this started already negative, I'm actually going to get a positive this time. Flip my fraction, 4/1, or simply just +4. All right, now let's bump this up. Good information. We're getting understanding what's going on with parallel, perpendicular, what we even mean, but most importantly, the slope that we connect with it. So now let's take that and let's go back to the problems we were doing in the beginning of section 5 in part 1. Let's go back to find the equation of the line. Number 1, we're going to find the equation of the line that is parallel to y equals 2/3 x minus 1 and goes through the point 6, -2. How am I supposed to do this? Well, remember what we were doing in part 1 of the video. We said if we want the equation of a line, the best way to approach that is to be thinking about your point slope form. I need an xy pair and I need the slope. And in some of the earlier ones, it felt like the slope was the hard part. Well, now, it still kind of is. The xy pair is right here. My x1 is 6, my y1 is -2, but I need the slope. What do I know about slope? There's no bogus questions here, everyone. I'm not giving you any not enough information. There's got to be a way you can find it. So you'd come up, what else are we told in the problem? The line we're looking for is parallel to this line. Hey, parallel lines have the same slope. What's the slope of this line? The slope is 2/3. So therefore I know the slope of my line is also 2/3. There's my slope, there's my point. Y minus the y coordinate equals mx minus the x coordinate. And as we always say, it's perfectly fine to leave your answer like that. But again, you certainly could solve for y. Same as always, here we just clean that up to a +2. Over here, a little distribution. 2/3 times x, 2/3 x. 2/3 times -6. Well, 2 times -6 is -12. -12 divided by 3 is -4. Finish solving for y. Subtract the 2 on both sides. Y equals 2/3 x minus 6. That is the equation of the line, or again, same thing here, and I can't say it enough. Perfectly fine to stop here. I just know a lot of people like to solve for y. That's a way to check a lot of answers, to confirm some different things. But now, before we go to number 2, I just want to make one change. Find the equation of the line, but this time let's change from that as parallel to perpendicular. Find the equation of the line that is perpendicular to this line and still goes through this point. Still need a point and a slope. Point is still given here, but now is where we have to do a little more. My line is perpendicular to this line. Well, this line has a slope of positive 2/3, so my line has a slope of -3/2. I negated it and flipped it. So now, this slope and this xy pair will plug in, still same xy, but different slope. Y minus a -2, m quantity x minus x. And again, folks, this is not the same question. So we're not getting the same answer here. This was the answer of the line parallel to this. This is the line perpendicular to this one. So I'm not expecting to get the same answer. I'm just pointing out, similarly, if you want to solve for y, similar work. Distribute over here, clean up over here. On this side, -3/2 x. Minus times a minus is a plus. 3/2 times 6. Again, calculators help, but old-fashioned, top times top, bottom times bottom. 3 times 6 is 18. 18/2 times 1. 18/2 is 9. Subtract the 2. -3/2 x plus 7 would be your final answer. Again, this was a good final answer, but just to see it, again, a lot of people have a lot of good practice, and sometimes they do like to ask you, put your answer in mx plus b form, so that's all we do. One more, and then we'll mention some special cases quickly, but one more big one, very similar to this. Find the equation of the line, same directions, but now number 2, let's find the equation of the line that is, we're going to do the same thing. We'll do parallel, then perpendicular. Start parallel to y equals, to -8x plus 2y equals 6. That is parallel to this line and goes through -4, 1. Such a similar question to what we just saw here, so let's attack it the same way. And again, folks, we'll do a part B in a moment. We'll do perpendicular. But starting with parallel, same approach. Have an xy pair. I need a slope. Oh, and I'm sorry, folks. I wanted this to be a plus 8x plus 2y. Here's the big difference. I need the slope of this line. Just like we saw up here, I've got a point, I needed the slope. The slope of this line, no matter which part we looked at, allowed me to get the slope of my new line. But in this one, to get the slope from here, I gotta put it into y equal mx plus b form. So I'm gonna take that 8x plus 2y equals 6. I'm gonna subtract 8x from both sides, cancels, 2y equals minus 8x plus 6. Divide both sides by 2. Here I get my y equals. Negative 8 divided by 2 is a clean minus 4. X comes down. 6 divided by 2 is 3. Now that line is in my better form. So now I can look at this and say, okay, the slope is minus 4. And if the slope is minus 4, and I've got this point, put it together, y minus the y coordinate equals m times x minus the x. The m and the x are the same value. Coincidences happen, no big deal. There's a good answer. And just one more time, you want to clean it up. Well, over here, that becomes a plus 4. Then I distribute minus 4 times x, minus 4x, minus 4 times plus 4, minus 16. Add the 1 on both sides. We would get y equals minus 4x minus 15. But again, perfectly fine up here. Just a little cleaned up, what a lot of people are comfortable with. But now we do that same problem, but now we ask for the perpendicular line to this one, but it's the same process. I need the slope of this line, but now because it's perpendicular, I need the negative reciprocal, not the same slope, the negative reciprocal. Negative becomes a positive. 4 over 1 becomes 1 over 4. That's the slope of the perpendicular line. Still have this as my xy pair. Y minus the y equals mx minus the x. And just to show you, I'm going to stop this one right here. You don't have to keep going forward. That is a perfectly good solution when the problem is just asking us to find the equation of the line. Again, I especially mention that on our tests. On our tests, perfectly fine to stop there. You don't have to keep going. You could use the time that you might, use solving for y. You could use that to double check another answer, make sure you get through other problems. That's a better use of your time. Last thing just to say quickly, what about the special cases? Well, if we're looking at a horizontal line, any parallel line would also be horizontal. Any perpendicular would then be vertical. So again, it's just special cases. If you start with a horizontal, parallel, still horizontal. If you start with a vertical, parallel, still vertical. But if you have a perpendicular, you'll always flip-flop. A horizontal is perpendicular with a vertical, and vice versa. A perpendicular is perpendicular to a horizontal.